Well, we're really excited to be here, and we are especially grateful for the opportunity that we have to present some of the information that we've studied to you, because we've learned a lot, and we are really hoping that it'll be something that excites you as well. So each of us, we feel like we have a really big passion for technology and also health, and we wanted to integrate both those things together to see if it was possible to create an optimization for exercising time. And in our pursuit of trying to achieve that, we've come across a lot of ideas, a lot of articles to really solidify our understanding not only of exercise but also of the heart. And those are some of the things that we want to talk about in this presentation. So as you can see here, go to the next slide. Right now you might be asking yourself questions like, what's the point of this, or what does it even mean to optimize your exercise time? Or maybe does this work for everyone, or does it just work for the subject that we targeted here? These are all questions that we had when we started the project, and ones that we want to, assess in this presentation. So our objective here, as you can see, is to optimize the heart rate in real time by providing a velocity feedback in real time as well. And we want it to work for any fitness level, anybody, on any route. So as you can see here, Tomo running, he did a really good job. Our control variable, as we said, was the heart rate while manipulating the running velocity. And it's pretty common to run into elevation changes on any route. So that was our disturbance, and we wanted to be able to adjust for that so we can maintain that heart rate. As you can see here on the bottom, this is a big part of why we wanted to optimize the heart rate, because there are certain ranges that you want to achieve to reach a certain heart rate intensity depending on what kind of, body type or what kind of physical results that you're looking for.
So in order to test our theory, we first had to model our heart. So we did an extensive study on how the heart function, or how it works to regulate its heart rate. We found two main systems that they use to regulate the heart rate, and we found that they use different for increasing and decreasing the heart rate. So we decided to make a two-step test for going up and going down in order to more accurately produce the what the actual heart would do. And you can see in this graph for the our FOPDT model, and we were able to fit it pretty well. And so for disturbance, we did the elevation change. And for this one, I basically ran a flat and a hill at the constant velocity, which was pretty funny to look at. You should have seen us running along the car. Anyway, and so that's how we got the disturbance model.
Okay, and then we took those disturbance models and the increasing and decreasing transfer functions, put them into Simulink. And we gave a feedback controller to each one of the models, the increasing and decreasing. And then we also included a feed-forward controller to account for disturbance. And when we controlled these PID controllers, we wanted to limit the overshoot to limit the fatigue a runner experienced when they were running. So we wanted to reach the set point but not overshoot it. And then we also wanted a quick rise time to really maximize the time someone spent running. And what we did was we simulated a run that BYU students probably commonly do is around BYU campus, and as shown in this map right here. And then we also have the elevation profile right here as an example, or the elevation changes that the runner would experience on that route. And we fed it in real time to the optimizer as simulating a real-time run. And this is the interesting outcome we had. As you can see right here, we have the grade changes the runner experienced, and then the response of the velocity that the optimizer outputted. And as you can see, it did a really good job of maintaining the heart rate within a desired level of intensity. But we asked ourselves, is this level of exercise and or optimizability going to be equal to someone with a lower level of fitness? And so we took the gains from the models for the higher level intensity and doubled them to account for someone with a lower level intensity. And as you can see, the optimizer did a good job, once again, keeping it within a reasonable level of exercise intensity and at the set point of 163 beats per minute. But you can see right here, the optimizer did tell the runner to run at a slower rate, average of about 3 or 4 miles per hour, whereas for someone with a higher level of fitness, it was about 7 or 8 miles per hour.
So as you can see here in the top graphs, as Ethan talked about, these both have really high, well, I guess not so much the low-level fitness, but the high-level fitness. We had an assumption that someone would want to reach the heart rate set point as fast as possible to really minimize the amount of time exercising. So in future editions of this, what we'd really like to do is give the runner the option to kind of input how long they want to take to reach that set point, give them the chance to kind of warm up so they don't just have to sprint right off the bat and maybe pull a muscle or something. But that's something we would really like to do. And in developing that edition, maybe put it on an app for everybody to be able to access it, because we really believe it's something that will work for everybody on any route with any elevation changes.